Right, morning everyone. So this is a rebuild of one of my old videos on power supplies to bring it a bit more up to date, but we're going to learn about different types of power supplies that are out there. You need to be able to name them and recognize them. So this is just very basic level stuff. Some of them you'll have heard of before. You need to be able to understand the pros and cons of them, the advantages and the disadvantages of each type, so that you could argue that in an exam question. And then if you were given a product, you should be able to pick what would be the most suitable power supply for that product and be able to kind of argue your reasons for that as well. So that's our learning objectives. This all comes out of OCR, Cambridge National Systems Control Specification, which is rubbish. They don't give you anywhere near enough information to go on, but this is what they give me. So you've got to know broadly different types of power sources, i.e. those, and then reasons for selection. So because I never know what detail they're going to go into in the exam, because this is all I get to go on, and there's no textbook to go by either, I'm kind of using my best judgment from teaching electronics for quite a few years now. So yeah, what I'm going to do, I'm going to show you the type of power supply and then just give you a little bit of a talk about it really. And then I'd recommend you guys take some notes, because you're going to have a worksheet to do on them for your homework. Or your school closure work, I should say. So, concept recap time. It's just a little bit of a starter. I'm going to throw a bunch of true or falses at you. Sorry, only one of the statements on the page is true, and if you're following along the video, maybe pause it, see if you can work out which is right, and then I'll tell you the answer. So, question 1 recap. Which of those is correct? Pause it if you want to guess. Okay, so your correct answer, nope, it's not measured in volts. Nope, nope, this is your best description. Current is the amount of electrical energy flowing through part of a circuit. Good, it's the flow of electricity. Second test, which of those is right? Pause it if you want to guess. Okay, correct answer would be number 3. This one, the formula is V equals I times R, just in case to trip you up. Potential difference and voltage are the same thing, different names for the same thing. And electric current doesn't always follow the path of most resistance. That's just not true in any way. Okay, have another guess. Okay, correct answer will be number 2. You cannot have a current flowing without a difference in potential between two parts of a circuit. We talked about this before, like current being, right, you can only have a current in a river. You won't really have a current in a lake. A lake is stored energy or stored water. A river is flowing water. It's got potential because one end of the river is higher than the other, okay? So current's the same. You cannot have current without potential difference. All right, and final one. Okay, answer number 3 is your correct one. Charge is in coulombs, so that's wrong. Resistance is volts per second. No, it's not, and it's measured in ohms, so therefore potential difference isn't measured in ohms. Okay, cool. Right. Down to you if you want to keep notes. If I was doing revision, I like to kind of do a sort of pictogram like this, picture of the battery, name the type, good points, bad points, down to you, and then the kind of products they use. Entirely up to you if you choose to do that. So I'm going to do my little lecture. Your job is to watch it and listen, and then try and answer that sheet I've put in your OneNotes. Okay, first type of battery type we're going to look at. This is known as zinc chloride. Okay, now zinc chlorides are the cheapest of the disposable batteries. These are the kind that you'd find in Poundland, the sort that you'd buy like 4 of them for £1, and they don't last 5 minutes because they're rubbish. Now, there are uses for them. The fact that they're super, super cheap, because they're very cheap to produce, makes them great for devices that don't need batteries changing on them very often. Think things like a TV remote. When was the last time you bothered to change the batteries in that? Probably not since you brought the television. So anything where any application where you don't need much electricity very often, and the price of other types of power supply would be a waste, if you like. So there's your advantages. They are very cheap, very common. You get them in all the different sizes. So things like AAA, AA, C, D, all those different size batteries, which we call batteries, but we should call cells, that you'll be familiar with. And the main advantage of any cell or battery is that they are portable. You can take the product places and move it around. You're not tied to a cable. So that's important. Downside of these, as it says, you can't really recycle them. I mean, there are recycling schemes available now where you can take them to your supermarket and dump them in a bin there, and they, not any bin, a special bin, and they will recycle them responsibly and try and extract some of the chemicals from them. But they're not easy to recycle in that sense, and it probably uses more energy to recycle them than they actually produce. They don't have much capacity, and they are toxic. This is one of the reasons you shouldn't throw them in with your normal rubbish, because eventually that gets into landfill, and if the landfill's not looked after properly, those chemicals can leach into the soil and poison water and kill all the fish and animals, and it's not good for the planet, basically. So, and the fact that they're so rubbish and don't last very long means that they don't spend very long in use before they end up in landfill. So really, these are probably the worst kind of power supply environmentally. Yeah, there we go. So that's zinc chloride. Right, next type we're going to look at. I'm sure you'll all recognise these. These are what we call photovoltaic cells or solar cells, solar panels, and these convert sunlight into an electric current. And you'll find them power on top of houses nowadays and calculators, as we've seen there. Good and bad. So your great positive of them, they're sustainable, i.e. they keep producing energy as long as there is sunlight. And that makes them good for the environment, because it means we don't throw them away every day or every week or whatever. In theory, they can keep going for a very, very long time. They don't really wear out. They do get dirty and less efficient, and I believe over very long periods of times they do wear out, but generally much, much longer lasting. So that's great. The downside of them, they suck at producing electricity, like really bad. They're improving all the time, and I think in sort of frontier science, the very, very most efficient solar panel is hitting about 45% efficiency. I think I read an article the other day, but that's like in, super sunlight with mirrors reflecting and concentrating it down to a point, basically a giant magnifying glass pointing at it. They're not very efficient, and they don't capture anywhere near the energy that's falling on them. So that makes them useless for powering anything that needs a lot of electricity. This is why at the moment, great for powering a digital calculator, which barely needs anything. And you might see them on houses and think, oh, great, they're powering all the houses. Well, they're not. They're supplementing the energy that the houses use, but they're definitely not providing all the electricity they need. Just to put it in perspective, the schools' solar panels that you've probably seen all over the place. So we've got all of Barossa, all of Q-Block roofing covered in them. The site manager one day was really proud, showing me the installation. He's going, yeah, it's brilliant. Yeah, all of these, yeah, on the best day last year throughout the summer, they were producing 12% of our energy. I was like, well, that's great. 12% is better than nothing, but that's on the hottest, brightest day of the year. They were only producing 12% of what the school was using. So it helps, but you're never going to run things off these long term. So that's your downer. They're also expensive as well, because there's lots of manufacturing that goes into them, and they're big and difficult to install if it's on a house. Not as portable because they're bulky and flat. They're quite delicate as well, the ones that work well, because they're made out of glass, so you've got to think about protecting them. And obviously the biggest issue, you need sunlight. And if you live in this country, we don't get that very often. So that means they're no good at night, and they're no good on a dark, cloudy, rainy day, which is why we get most of our sustainable energy in the UK through wind power, which we have a lot more of, and sort of hydropower as well is a better solution for us. And also they don't store energy. This is going to come into play later, right? They don't store up electricity. They only make it while sun is shining. So yeah, that will be a clue for one of the products you'll see in your worksheet. Okay, these guys. You'll go, Duracell batteries. Well, actually, remember, these are all called cells. That's a cell. That's a cell. Just a little refresher here. If you join them together, like one to the end of another, then it becomes a battery. But we're in the habit of calling them batteries, okay? So anyway, this type, you're probably like, well, how is this any different to the ones you were shown on the first page? Well, this is a different technology. This is called alkaline. So the reason I picked Duracells for this is Duracells are a pretty well-known brand, an expensive brand. You know, you'll spend £3 or £4 on a pack of 4 Duracells, where you could buy 4 packs of 4 of the cheap zinc chloride ones for the same money. The reason they're more expensive is because it's basically a better battery chemistry. It makes them last probably 3 or 4 times longer. So that's better. They last longer, which means they don't end up in landfill as quickly. They've still got all the benefits of other cell types. They're, like zinc chloride, they're portable, they're common, readily available, easy to get hold of. But you've still got to throw them away at the end of their life. And again, the chemicals in them are still not great for the environment, so they need to be recycled responsibly. And also, compared to zinc chloride, they're more expensive. So for a product that's not going to use much electricity very often, it's probably overkill spending money on Duracell batteries. If it's something like a kid's remote control car that's got that's got a motor and lots of things that need a lot of electricity, this might be a better choice. But if it's something you're going to use all day, every day, over and over again, still not a good selection, because it will run out and you'll be forever replacing them. Okay, so better than zinc chloride, more expensive, still bad for the environment. All right, these guys, these are known as lithium coin cells, as it says there. And you've probably seen these before in things like watches, greetings cards, like musical cards, anything where you need a power supply in a very, very, very thin or very small space. Like my kids have got loads of musical books. These are all powered off those. Yeah, that kind of thing. Now, they are still disposable. Don't let the word lithium confuse you, because we're going to get onto another type of lithium battery later. But these lithium button batteries or coin cell batteries are disposable, as in they run down. Their main advantage is they're super tiny. So for their size, you get quite a high voltage out of them, which means you can power electronics, because, circuits and things, and integrated circuits, chips, they need a certain voltage for them to be able to work. These give high voltage for their size. Not much current necessarily, but they are super small and compact. And again, same downsides as any of the batteries that are non-rechargeable, really. You've got to throw them out. They're toxic and they're expensive. For the amount of electricity you get out of them, or the amount of charge they hold, if you like, they are, I shouldn't say charge really, but the amount of electricity they can supply, their density, they are very expensive. Okay, there we go. So lithium coin cells. Right, we're on to our first rechargeable technology now. This one might be familiar to you as the kind of thing you'd see in Halfords. And that's because these are fitted to nearly every car out there on the market at the moment. Now, the car doesn't run off this. This is a battery used for starting the car, and the technology behind it is called lead acid. Now, lead, if you know anything about it as a metal, is very dense, which means it's very heavy. So lead acid batteries are incredibly heavy. And that's all right for a car, because you've got a petrol engine to pull all that weight around with, and you only need one of them to start it. So it's not too bad for a car, but you wouldn't want one of these things powering a mobile phone. If you go back to the early 80s, the 80s, when the first mobile phones came out, the comically huge ones, giant brick-shaped things that you needed 2 hands to lift, they might have been running off lead-acid batteries, and that's part of the reason they were so bulky, just because there was nothing else really available at the time to power a device that needed a rechargeable battery. And lead-acid's been around quite a long time. I think, probably a couple of hundred years, at least over 100 years, 150 maybe. I'm sure before the start of the 1900s it was around, and it's been powering cars and submarines and things like that ever since. So quite a crude chemistry. But the good thing about it, it's rechargeable. You can recharge these hundreds, if not thousands of times. A rechargeable a lead-acid battery in a car might last 6 to 7 years, sometimes 10 years if you're lucky, which is really good. And that's, starting a car every day, every year, 365 times a year being recharged. They deal with hot and cold very well. They're cheap to make for the amount of energy you can store in them. And they can provide a lot of electricity really quickly. That's what this cranking current thing means. And that's really important for a car engine. It takes a lot of current to make the motor in a car engine turn an engine over. Incredible amount of current, and these things can just push it out all day long, which is why it's very important if you ever get working on your own car, don't drop a spanner across the battery and accidentally join that thing to that one with a spanner, because that will make a big spark and get very hot very quickly. And yeah, anyway, just a little aside there, thinking back to my early days of fixing cars and making sparks near fires. Anyway, cons. They are heavy. That's it, really, and they've still got toxic chemicals in them. And they do take a long time to recharge, as I've said there. Compared to modern rechargeable batteries like you get in your phone, which is a different chemistry, these take quite a long time. It's fine in a car engine because it's charging all the time you're driving. And again, they've got to be responsibly disposed of, but they can be recycled for the most part. Okay, so lead acid, rechargeable, that's good. And still semi-portable, but not ideal for modern electronics. Right, these things are kind of a bit old hat now. So this is what we call NiMH, or this little logo here, NiMH, stands for nickel metal hydride. And this is a kind of older rechargeable battery technology that was sort of around in the 90s, early 2000s, but has kind of been replaced nowadays with another one we're going to look at called lithium ion. And you'd have found these in those rechargeable batteries you can buy to use instead of Duracells or zinc chloride ones. You find them in like remote control car battery packs for anyone that's into RC cars or RC aeroplanes. Power tools, the early generation of power tools were powered by nickel metal hydride, and they're good. So your benefits, compared to lead acid, it's a lot lighter for the amount of electricity you can store, and they charge a lot quicker than lead acid, and you can get them in all the common battery sizes. But the downsides are, as usual with battery technology, chemicals, and more expensive to buy. So comparably, just to give you an idea, so let's just say 4 zinc chloride batteries, you know, the pound-lound ones, they might cost you £1. 4 Duracell batteries, alkaline, they might cost you £4. 4 rechargeable batteries, decent ones, they might cost you £5 or £6. So they're always going to be more money. But they pay for themselves. So this makes them really good for any product that needs to be used repeatedly, you know, every couple of days, and you wouldn't want the aggro of changing the batteries over every time they run out. So that's why they're great for power tools, remote control cars, and when I say RC cars, I mean kind of expensive ones, you know, sort of the more ones that enthusiasts would buy rather than the kind of cheap one you'd get in a Christmas present. You know, the sort of cheap £10 ones, they might be better run off alkaline batteries because you probably only use them a few times before they get broken. But a serious remote control car or plane might use this kind. Although saying that, nowadays these guys have been replaced with another type, which we'll get onto in a second. Okay, so NiCad batteries, main advantage, rechargeable, and you could probably add portable to that list as well. Anything that doesn't have a cable is portable. Okay. Right, this is the modern world, and I say modern, but these have been around really since the early noughties, even a little bit earlier. This is known as lithium-ion batteries, and you will find these in your mobile phone, laptops, any modern portable electronic device. And to be honest, most modern power tools, drills and saws and whatever, tend to use lithium-ion now as well because it's just better in every way. Compared to NiCad and lead acid, it's got brilliant energy density. So they're obviously rechargeable, super portable. They can be made really light and thin and still have really good energy capacity. And that's what really has made modern phones, modern laptops, and even things like Tesla, which runs on a variant of these, possible. Because finally we've got to a stage where we can cram enough electricity into a battery that's light enough and small enough that we can power hungry things with it, like phones and cars, and they're also quick to recharge. You probably know your modern smartphones can do quick charge and be like 80% full in half an hour, where it used to take all night. Much higher energy density than the other types, and long lasting. They're pretty reliable. When I say long lasting, what I mean is you can leave the device turned off and the energy won't sort of dissipate out of the battery, whereas with some of the other types like nickel metal hydride, the battery will slowly run down over time. And they don't suffer from this memory effect thing, which a memory effect this is a problem with some battery types. If you if you flatten them too far, like lead acid and nickel metal hydride, and then try and charge them, you permanently lose capacity. Whereas lithium-ion batteries can be taken pretty much completely flat within reason, and they recover from it. The downsides to them, though, is all of that benefit makes them more expensive. They've still got toxic chemicals in them, which makes them difficult to recycle at the moment. And to be honest, that's going to be one of the hurdles for designers of the future, is to figure out how we can start recycling lithium-ion batteries in big scale, because the more and more electric cars are on the road, the more and more lithium-ion battery packs there will be that need recycling. Same with all those smartphones that eventually end up being recycled. And the big one, fire hazard. This is quite problematic. If the battery chemicals get exposed to oxygen, they spontaneously burst into flames, and you can get some pretty epic fires. If you want to go down the YouTube rabbit hole, search lithium-ion battery fire. And this means they have to be well protected. If they get punctured, they can go up in flames. They have to have special circuitry while they're charging to monitor the temperatures of them and the voltages and make sure they don't overcharge or overheat, because that can cause them to catch fire. And they do suffer from aging effects. You'll know that your mobile phone battery isn't as good a year later as it was the day you bought it. And after a certain number of cycles, they start to lose capacity and therefore need to be replaced. So that's something that needs to be considered as well. But generally, they're the best thing we've got at the moment in terms of rechargeable technology. Okay, so I'll leave it down to you to figure out which type of product would have those in it. This you might look at as going, well, that's a bit like my phone charger. It is. We know this is a DC transformer. So what these guys do is they plug into the wall, your plug socket, and they take your 240 volts mains electricity, which is AC, and they turn it into whatever's written on the front. So in this instance, this particular one takes 120 volts AC, so that must be an American one, and it turns it into 12 volts DC. So it turns it from alternating current, which goes backwards and forwards, into DC current. And that's really useful because most electronic gadgets, gizmos, your phone, your computer, laptop, your cordless phone, all use DC electricity, direct current. Not many things around your house, apart from big appliances like maybe your washing machine, use alternating current. All your smaller gadgets tend to use direct current, okay? And so we need to be able to turn mains electricity into direct current, and that's what these guys do. Now, I'm not going to go into how they work. They basically use a transformer and a thing called a rectifier, which you don't need to know about at this stage, but it turns mains electricity into good old-fashioned DC that you get out of a battery or any other supplies we've been looking at so far. So that's great, because they're powered from the mains. You have limitless power from the national grid. And you can have as much or as little current as you need based on the size of the transformer. It turns mains into DC, as we've said, and that makes them much, much, much more sustainable than any of the battery technology for certain things. So, for instance, powering a desktop computer or an Xbox off one of these is far more energy efficient than if you had to keep getting rechargeable or throwaway batteries and put them in. But the downside of having a cable, of course, is you're attached to the wall. You can't go anywhere with it. It limits your portability. It does make them more expensive to buy as well, as these things called transformers have lots of copper in them, copper windings of wire. If you've done a science lesson on how transformers work, you'll understand why. And it also makes products bigger as well. So if you look at your Xbox, if it's like my one, the power supply isn't even inside the Xbox. I mean, the Xbox is huge as it is, and then there's this other massive great brick thing that attaches on a cable to it, and that big brick is the transformer. It's the power supply that turns mains into the DC current that your Xbox uses, and that adds to the bulk. So these things ruin portability and they make things larger than they need to be, but limitless energy is your benefit. Okay, right, that's pretty much the different types you need to know. So I'm not going to give you the answers for this, but for anyone in YouTube land who's not my student who's watching the videos, my students broadly are going to be given these products and asked to discuss which of those power supplies we've looked at would be the best suited. So we've got garden solar lights, and there's 2 power supplies needed for those if you think about it. Digital watch, a cheapo remote control car, the kind that you might get for a tenner, not a professional one. Car keys, one of these. You've seen one of those before? An old cordless phone. There's probably one in your house somewhere gathering dust. Everyone uses their mobile nowadays. TV remote. Just a car, nothing fancy, not a Tesla or anything like that, just a regular car. Modern phone or modern laptop. A emergency torch. So I stress the word emergency here. I want you to think how often an emergency torch gets used. That might give you some indication of which, cost versus ability needs to be decided on with this one. Musical greetings card. Very, very thin, very, very small. Think about it. An Xbox and the controller, maybe a couple going on there. And that's it, really. So that ends this lecture. You can rewind it and go back through it, and there's all your pros and cons for you, and I've pretty much given away some of these in there. Okay, but that's basically it. Zinc chloride, solar, alkaline, lithium coin button batteries, lead acid, nickel metal hydride or NiCad. Sorry, these are two similar ones. I need to update that. NiCad and NiMH are the same kind of technology. Well, they're different but similar in terms of ability. Lithium ion, the modern wonder. DC transformers. There we go. All right. Thank you for watching. And here end of the lecture.